Hi, welcome to my channel EasyML. In this video, let us summarize the whole workflow when it comes to dimension reduction. Let us examine the steps when it comes to building a dimension reduction model. Recall, the main aim of dimension reduction is to group variables that are linearly correlated and present them as new variables that are linearly uncorrelated. The first step when it comes to building a dimension reduction model is to check whether the variables within a particular dataset are eligible for dimension reduction or not. So, we build the correlation matrix to check whether the variables are linearly dependent or highly correlated with each other or not. The stats package in R has a function called the cor function that can help build the correlation matrix. Now, let us move on to the next step, that is building the dimension reduction model. In the introductory video, if you remember, I had mentioned that there are various ways to perform dimension reduction. But in this course, we have only explored the principal component analysis technique. The stats package in R has a function called princomp, which will help execute PCA in R. Now, let us move on to the last step, that is to evaluate principal component analysis. Recall that there are two ways to evaluate whether or not PCA has been correctly executed. First is by looking at the loading matrix to check whether or not the principal components capture the essence of the original variables in the dataset. And second is to examine the correlation matrix of the principal components to check whether the principal components are independent or not. The stats package in R has a function called the cor function that can help build the correlation matrix on the principal components that we have derived. And the loading matrix is available as a part of the princomp function from the previous step. Well, this brings us to the end of dimension reduction and hence unsupervised learning. Thank you.